Hi, everyone. I hope you're having a great day. Here is a 4.4 Adams method. You're gonna see that it's very similar to Jefferson's method. Just a review of Jefferson's method asks us to calculate the standard divisor and standard quotas, and then find the lower quotas. So we would just take the standard quotas and round all of them down, and then add them up and see what that adds to. If the total apportioned seats is too high, then you're going to increase the divisor. If the total apportioned seats are too low, you're going to decrease the divisor, and you're going to calculate the new modified quotas and then add them up, see if it equals the total number of seats that we're trying to apportion. If it doesn't, then we're going to, we're going to repeat steps 2 and 3 until we find a divisor that works. So that's our Jefferson method. But Adams method is very similar. We're going to do this. It's also a modified divisor method. So basically, we're going to start the same step, calculate the standard divisor and standard quotas, just like the first step of Jefferson's. Except step 2 is different. You're instead of rounding them down like we saw with Jefferson's, we're going to round them up. And we're going to add them up, and we're going to see if they happen to be equal the exact amount of seats that we wanted to hand out. If it doesn't, we're going to follow the same rules as Jefferson. And for all divisor methods, we follow these rules. If the total apportioned seats are too high, then you increase the divisor. If the total apportioned seats are too low, then you decrease the divisor. And then you would calculate, once you find that new divisor, you calculate the new modified quotas, you'd add them up and see if it equals the amount of seats that you want to have. And then we're going to go back to step number 2. If it's too high, then you're going to increase divisor, too low, then you decrease divisor, and then you calculate the new modified quotas, and then you check and add them up, and you check to see if that's the right amount until you get the right amount of seats, right? And the right amount is the amount that we are supposed to be delivering out, right? So that's Adams' method. So once again, the only difference is step 2, where in Jefferson's, you round down to the lower quotas, and in Adams, you round up to the upper quotas. So they're very similar. So let's see an example. So a large hotel chain needs to apportion 30 new surfboards for its visitors to rent among 3 hotels based on the number of rooms in each hotel, as shown below. Using Adams' method, answer the questions below. So they want us to determine each hotel's standard quota and the corresponding apportionment from the standard quotas. So I calculate the standard divisor and standard quotas. What I do is I totaled up all the rooms. So that was 239 plus 159. So 239 plus 159 plus 412, and I got 810. So that is the total population. That's the word that they like to use in 4.1. Or here it's the total number of rooms, right? And between all these 3 hotels. So we take our population total to find the standard deviation, standard divisor, sorry. We take the population total, which is uppercase P, divided by the number of seats. That is the number of things that we're trying to divide up between those the hotels, and that is the 30 surfboards. So it's going to be 810 divided by 30, and we get 27. Exactly. Nice. So that means we're going to be giving one surfboard for every 27 rooms in a hotel. So we need to know how many 27s are in 239, in the 239, how many, so that when we answer that question, that's going to be our standard quotas. So I just take each number here, 239, and I divide by 27. And this is a standard quota. And I get 88.52. So I wrote that so you guys see what it did, but I'm actually just going to write the standard quota here. The answer, 88.52. Okay, then I'm going to do 159 divided by 27, and I'm going to do 412 also divided by 27. But I'm going to quickly calculate what the answers are and just write them there. All right, and now I'm gonna go ahead and add them all up, and just maybe this happens to just work out magically somehow. And well, wait, let me go. First of all, this method says, Adam's method says round up, right? In the instructions here for Adam's method is round up. So we're gonna round up, and I get 9, 6, because we're just rounding to the number. There's 8.852 is the number between 8 and 9. So I just round up to the higher number 9. And then 5.889 is the number between 5 and 6. So I round up to 6. And then 15.259 is the number between 15 and 16. So we round up to 16. To find the rounded up number, you could also just ignore the decimal. So ignore this 0.852, on this first number, and then just add 1, to the whole number to get to round up, right? I could have ignored the 0.889 and just add 1 to get to 6, and then I could ignore the 0.259, just add 1 to the 15 to get 16, right? Okay, but anyways, I round up. And I'm gonna add those up and just see if it happens to equal this total of 30 that we want to give and 30 surfboards that we want to hand out. So 9 plus 6 is 15, plus 16 is 31. So it's not exactly 30 like we need it to be, because this total, when we get done rounding up, it needs to be exactly 30. It's not exactly 30. So reading in step number 2, it says if the apportioned seats are too high, which they are, we need them to be exactly 30 because we only have 30 surfboards. And here we're handing out 31 surfboards, which we do not have. So the instructions up here say if the total apportioned seats are too high, then increase your divisor. So I was dividing by the divisor here. The standard divisor was 27. So let's try 28. It's slightly larger, right? Increased from 20. So instead of giving them 27, give one surfboard for every 27 beds, we're going to give them one surfboard for every 28 beds. So I'm going to do the 239, and this is a modified quota because we're using not the real standard divisor, not the standard divisor, but a modified divisor. So we call this a modified divisor. And I just made up 28 because they said increase 27. And I was like, okay, well, just go up one by one. We'll see what it does. If it doesn't work, we'll try something else. Okay, modified divisor. Oh, wait. This is, and I'm going to be calculating modified quotas with the modified divisor of 28. And I'm going to just say D equals 28 here. And to calculate these, I'm going to do 239 divided by 28 to 159 divided by 28 and 412 divided by 28. So a little bit ago, when we did the standard, we were dividing by 27. We increased the divisor because there's too many seats. So yeah, now we're going to see what numbers we get. So I wrote out the math that I actually did, but now I'm going to erase them and put the actual answers because I found the answers in my calculator. So 239 divided by 28 is 85.3 or 8.536. Notice how like it didn't really change that much from the standard quota. It went from 8.852 to 8.536. So actually, we're going to round that up to 9. Their apportionment is not going to change. Now, if I picked a divisor that was a lot, let's say I picked a divisor of 35. They said increase the divisor, and I said okay, 35. If I divided 239 divided by 35, let's see what that is. And I got a hugely different number than the standard quota there of 8.852. I might be a little concerned because we want the standard quotas just to change a little bit, maybe by 1 or 2 numbers, because we want the apportionment, we want to apportion 30 seats, and we're only off by a little bit, just by 1 seat. So we don't want these numbers to change, these quotas to change that much. Maybe we just want only one of them to change. So if I would have chosen a modified divisor of, oops, let me fix that. All right, if I would have picked if I would have increased instead of to 28 to 35, then I just did 239 divided by 35. That would have given us 6.82. So that would have changed the it would have changed the standard quota would have gone from 6.8 to, no, I'm sorry, 8.8 to 6.8. So it moved 2 numbers, and that would have been too big of a move for us because we only really we wanted just one less seat. So that can kind of help you just by checking and that first number of rooms and seeing how much the number goes up and down from the standard quota to kind of tell you if maybe you picked a divisor that was too small or too, before you go do all of them with like the wrong divisor. Anyways, 159 divided by 28, I got 5.6. 5.679. And then 412 divided by 28, I got 14.714. All right. And I'm just going to continue. I ran out of space right here, but I'm going to continue down here. Now we would round up because that would be the apportionment. So I would round up, and I would give this person 8.5 is going to round to 9, 5.6 is going to round to 6, and 14.7 is going to round to 15. Now I add them up. And that equals exactly 30. So that is the apportionment we want. That will work for us. So we're going to say that Hotel A gets 9 surfboards, Hotel B gets 6 surfboards, and Hotel C gets 15 surfboards. Now, if that didn't work, if we didn't add 9 plus 6 plus 15, and if we did not get 30, let's say we still got 31, then we would follow the rules again. If the total apportionment of seats are too high, then we would have increased the divisor a second time, or if we added these up and we got 29, then we would have said, okay, if the total apportionment is too low, which 29 is too low, then we would have decreased the divisor. So we would have picked a number between the first divisor we chose and the second divisor we chose. So that is Adam's method. So let me know if you have any questions. And like I said, it's kind of, you're going to feel like you're kind of guessing and checking a little bit. But if you follow these rules, and these are rules that are good for all the divisor methods, that's Adam's method, Jefferson's method, and Webster's method, and actually the Huntington-Hill method too. And the rule is, if the total apportioned seats are too high, then increase the divisor. And if the apportioned seats are too low, then decrease the divisor. And so if we just focus on those two rules, and we just keep trying and trying again with different divisors, eventually we're going to get one that works. All right. Have a great day. Bye.